Next up, we have Ju, who's going to be speaking to us on the thrilling topic of peeling zeros in Idris. How mysterious. Please join me in welcoming Ju. Thank you, Ju.
Hello. Okie dokie. So Idris, right? I created a little file here, and I think I wanted to say this at the beginning. Feel free to interrupt me at any time, and I really mean it. It's like don't feel like you're heckling or anything like that. Like if there's anything you have questions, just like interrupt and I'll stop. Yeah. We all know functional programming with types, right? You can do add x plus y, and you can ask the compiler to check this. And this is great. I think if I had to do like a 1-minute elevator pitch about Idris is that in Idris you can do this at a different level as well. So if I wrote a function called surprise, you can take a bool, and this thing will emit a special value which is called a type. The type can be any type, right? Not only this, but usually I think what's pretty cool about Idris the first time you try it, it has some really nice editor integration. So I can ask Idris, oh, would you please complete this function for me? And Idris starts saying, oh, okay, you want something like this. And you see that on the right-hand side, we have this, which is called a whole. And it's something like, it means like the program isn't complete, right? But at the same time, if I ask Idris to verify this, Idris is flexible enough not to crash just because my program isn't complete. It will still do something and it will try to do the right thing. In this case, for example, I get a bool and I can ask Idris, oh, would you please give me all the available values of this bool? And if I ask this to Idris, Idris will automatically compile everything and do this for me. And I just wanted to show you, if now I check, oh, it's still compiled, right? Okay, and let's say like now here, this is like the magic sauce, right? Like if I do false, I can return an int. If I do true, I can return a string. And it is like the weird thing, like normally you're not allowed to play this special type of game. Like this is not what like you're supposed to do. Normally you are constrained to this realm of values. But in Idris, as you can see, there's not much even ergonomic difference in playing, with this other type of existence. And right now it seems like a bit pointless. So I'm going to write another pointless function to prove my point. And I'm going to say this is called Stringify. And it's going to be a bool. And then I'm going to pass an int. And the result of this foobar function is going to be surprise of Stringify. And you can see, like, normally you're not allowed to do this, right? Like, normally you can't do like your things like that easily inside this. Normally it's like the realm of the compiler, right? But that's not enough. I can also ask Idris to please help me out here, and I get a Stringify. I can ask Idris to please give me the possible values of Stringify. And now I can also ask Idris, well, what do you think we should do here? And you see that I basically ask Idris to give me like a summary of all the types that are in play. And right now Idris says, oh, you have an x, which is an int. And then we have something on the right-hand side, which is supposed to be an int, because I ran the surprise function and I notice it's going to be an int. So in these cases, I can ask Idris, well, Idris, like, what do you think I should do? And it runs like this quite simple, like puzzle game and tries to fill up the hole. And you see like it still compiles. If I ask the same question here, Idris says, oh, there's an x, which is an int. There's a foobar right-hand side 2, which is a string. So in this case, for example, if I ask Idris to try to complete this, you will just say, well, I couldn't really find anything, right? So now if I do this little cast and I try to, yep, and this works. Actually, let me just do it here. Idris to Elm Meetup. Idris, and I do foobar false 4. Maybe I can also print out the type with an int. Instead, if I do true, it's a string. And actually, if I print it out without this value, you'll see like the actual literals. And I think this is, like my elevator pitch about these things at a slightly different level. Let me just close battle.net. There we go. Let me just quickly check if there's some questions. No, beautiful. So this is the point. Like being able to specify more stuff or slightly different things in the type system. I'm not sure if I'll be able to go through the whole talk, but the idea of the talk is slightly different from this introduction to Idris. The idea of the talk is about this special idea in Idris. Let me just do this. I'll show you. So let's say we have a list called the Beatles, right? And normally, when you have a list like this, as a human being, I can see there's 4 elements, right? But let's say in Elm, if I did something like get at 0 of the Beatles, this thing would get me just John, right? And I think there's like a little bit of mismatch here, because as a human being, I know that this thing is safe, but the compiler doesn't know that, and therefore I have to sort of play this weird game with the compiler where I know something, the compiler pretends he doesn't know it, and we just go back and forth. And I think another example is like when you're working with a map and you put something in the map, and immediately afterwards you want to retrieve that, and the compiler tells you, I don't know if it's there or not. Well, so I think like computers should do better than that, right? So for example, in Idris, there's another data structure called a vector, and I can say this thing is a vector, and I can say this is a vector of size 4 of string. No, sorry, I should have just reloaded Elm Meetup. There we go, and I can do vect index 0 the Beatles. No maybes involved. Like no maybes were harmed in the preparation of this presentation. And this immediately will be, well, what happens if we press pen to this though? Well, it crashes. It says something about cannot find a new implementation of something. But I think this is like more or less what I would expect, right? I would expect that if I specify like a static list, the compiler should be able to infer this information. And in the same way, for example, let's say I forget about one of the Beatles and I ask Idris. Idris says, oh, there's something wrong here. And don't read the error message, just look at this red caret. It says, look, the problem is here. And the same thing, for example, if I added something more, you'll see like Idris will still tell me, I think there's an issue here, like something's not right in the state of the world. Let me see if there's any questions. Ringo was harmed during the recording. Yep, he was deleted. So I wanted just to do like a little investigation of how's it possible? How can this work, right? So if I ask Idris, what is the type of that index? It will tell me it's like this special function. I'm going to maybe just paste it here. Right. It's a function that takes something called the fin. It takes my vector and returns an LM. Great, I'm interested. What's a fin? You can see it's a definition of numbers strictly less than some bound. The names come from finite sets. And I want to focus on the constructors of this thing. You see, like first of all, like this is like a fin. It takes a natural number and returns a type, like we saw before with our surprise function. So you can just see it like as a function. It takes a natural number, returns some sort of type, and these are the 2 constructors of it. So I'm going to paste these ones as well. And they look really weird, right? Like they're like, what the, I don't know, like there's like too much stuff. So I think we need to quickly look at what is this S? So there's this idea that natural numbers can be represented with a type, which is like it can be either 0 or the successor of a natural number. So for example, if I type 0, you see that Idris understands that it's the same thing. Then if I ask for the successor of 0, it's the same thing, and I can do the same. And this is called like piano numbers representation. You can represent natural numbers using this little type trick, right? So that's fine. So we know a little bit more about what this S means. Like SK means 1 or greater, right? And so I think it's still like a little bit confusing. Like when I look at the type signature like this, I don't really understand. Like, how's it possible that eventually, I get to a point where I do vect index 10, it doesn't work, but if I do 0, it works. You're like, something doesn't seem right. Like how can the compiler know this? And the trick is here, is like right in front of our very own eyes, but we can't really unpack it yet. So I'm going to try to do something first. So if we think about what is fin1, right? It's the set of numbers strictly less than some bound. So if you think about it, it just means there's only one element inside the set, which is 0. So in Idris, there's a little function called the, where you can specify a type, and then a value. So if I say fin1 of 0, you can see that Idris recognizes this, says, okay, yeah, this is perfectly fine. But if I try to ask Idris, give me a value 1 inside of this set, which shouldn't be right, you can see that it emits a very similar error message that we saw before. It says, I cannot do this, like something is wrong, like I cannot implement this. And the same way happens when we do something like fin0 of 0, because if you think about it, fin0 is the set of numbers, of natural numbers that are less than 0, and clearly this is an empty set. It's like an uninhabited set. That's the word. So there's no number, which can satisfy this constraint. And yeah, so let's try with another set. Let's try with fin2, right? If I ask Idris, can you get me a 0 of type fin2? Idris says yes. Can you get me a 1? No problem. Can you get me a 2? Oh, I can't find an implementation. So I think we got like a little bit of an idea, like the way that these things works, but we don't really understand, I think, the specific. Yeah, at least like when I looked at it, like in the first place, I couldn't really understand, but how does it actually do it? Like, I can see the results, but I don't understand how this type can do this, right? Like there's like a little bit of a mismatch there. So one thing I want to clarify is that the 0 inside here and the 0 inside here, they're different. And in a sort of way, I think we expect this, right? Like they're literally different types. So we're comparing apples and oranges together. So even though they're both 0s, they belong to 2 different sets. So just by the fact that for us human beings, they're basically the same, it's not true, right? Like they're actually representing different types of 0s. So that's the first observation. The second observation is this. If I look at these 2 numbers, one is fz and the other one is fs of fz. But these 2 fz's are not the same. These 2 fz's are of different categories. And if we look a little bit at this fs function, we notice why. The fs function takes a number and gives us the successor of that number. So in this case, we call fs on something which has to be basically fin1, right? So if I call this the fin1 of 0, it will give me this. And if I compare this to the fin2 of 1, I get true. So this is the proof that these 2 fz's that I've seen are really different. And if I try with the next set, it will be even clearer. that if I do fin3 of 0, it's fz, and these three fz's are of different categories, right? Like they're like different types. And the way that this type trick works is that the type system is trying to fill in the spot, right? It's trying to, oh, you want me to create a value 1? It means I need to apply this fs once. You need me to create a value 2? It means I need to apply this fs twice, right? But if you ask me to create a number 3, then I would have to apply this fs function 3 times, which is not possible because, as we've seen before, the fin0 set is completely empty. So there's literally no way that the compiler can solve this little problem, right? Like it's just like by design of this type, it is not possible. So if we look at the error that we get when we do back index 10 the Beatles, this is exactly what the compiler is trying to do. It's trying to figure out, well, can I do this operation? And it's actually calling this little function called integer to fin, which returns a maybe. But since you cannot do that, all hope is lost. Right. Piano numbers, yep, dependent types, that's exactly the thing. So I'm going to blow your mind though, because I cheated a little bit. And I think up to this point, you're like, well, this like seems like, you pay a price for this, right? But what if I told you that you can get all this for free? That would be cool, right? If I just refreshed and I did list.index 0 the Beatles. What? This shouldn't be right. Like usually you can't get anything for free. But in this case, somehow Idris is still able to understand that you can quickly get John from the Beatles, but you can't get something at index 10. It's actually a type error to try to get something out of the Beatles at that range. And I think I'm not going to explain in detail how this works. I wrote a blog post about this, but basically there's this special type called inbounds, right? And I am just asking you to squint a little bit and look at how inbounds is defined. You can see it's like quite similar to what we've seen before. There's like two constructors. One is the base case and the other one is the recursive case. And in the base case, we do something like 1, we do inbound 0 of like a non-empty list, I guess. But in later is the recursive case, and it goes from inbounds of k to inbounds of the successor of k. So if we look at this, it's basically the same shape. Like we're going from a number to the following number. And in this case, we're also peeling off an element from the list. So basically, this is how Idris, instead of like resorting to this number, it's using the actual contents of the list to try to satisfy this constraint. And for example, if I did list index of 0 of something which is empty, you will see like it says, oh, I cannot find an implementation of inbound 0 of the empty. And if we look at this, it's perfectly clear why, because the definition requires that second element to have at least one thing. If it doesn't have anything, it cannot satisfy that and it just fails. But if we do have something, it will just work. And the same thing is, for example, for the old problem of list head of an empty. You see, there's another little thing called non-empty that does the trick. And if instead there's something there, you get it. I think my time is up. So I think I'm going to stop presenting.
Let's thank Drew for his talk. Thank you, Drew. As I'm sure there are many questions from that mind-blowing. Let's dive in. So questions for Drew.
So will that even end up in the binary at the end, or will it be not in the binary at all?
I don't know. I think it's not going to end up in the binary in the case when the list is a literal. I think it will be erased.
So there are virtually no performance implications.
Yeah. I think so. I think in this case, I can think of some cases where, for example, the list is dynamic or like it's a result of a filter operation. And I guess in that case, like you wouldn't possibly know if it's empty or not. So I don't think you will be able to resolve this special constraint at that point. But so I think for those, there's like a safe version of these functions, which returns the maybe. But I think for these specific cases where the list is known or you have some guarantees, for example, I just pushed something to the top of the list, so I know that something is going to be there, right? Then I know that that list is going to be non-empty, and I know that if I grab the first element, something is going to be there. I'm just going to post. I wrote everything down somewhere. I hope the link is right. Yes, it's right. So there's like more details about how the inbounds thing works, and I think like it's a bit weird maybe when you listen to this talk the first time because you're not used to talking about zeros and finite sets. It's quite boring. But yeah, I'm sorry.
Mario did that thing about two types being different when they looked the same. Sound familiar to you?
Yes, that sounds like a nightmare. Extended and dangerous. But it's also very cool.
I think that reminded me, like I think like many years ago when I was doing algebra, there's like this idea of like different categories of zero, right? Like if you draw a curve, this curve can get closer to zero at sort of like different orders. So there's like this idea that not everything that goes to zero in the exact same way, and there's a way to define this in math. And I think like it's like sort of similar, right? Like just because something is going towards zero or is zero, it doesn't mean it's exactly the same zero. And actually, the fact that these are different zeros gives us the ability of like limiting how many numbers we can create. And I think like like that's why I think, well, I should have said this, but the title of the talk is because you think of this initial zero as the big zero, right? And in order to get a 1, you need to remove a layer and get a 1. In order to get a 2, you have to remove another layer and get a 2. In order to get a 3, you have to remove another layer. And at some point, you won't be able to do that by the construction of the type. You'll get to a point where you get to fin 0, and fin 0 does not have any value that can satisfy the requirement, and therefore you're just it's just impossible, right? Like for the type system to resolve this problem, and therefore you are saved from making a mistake and trying to read a beetle that does not exist.
I have a question. What are the main applications of Idris? Like, what kind of stuff do you see it used for most often?
I think it's quite like a general purpose language. So the way I've played around with it is just like to write normal programs. You can just specify some extra constraints, right? So I just feel like as opposed to, for example, something like Haskell, I think they try to keep the language relatively simple. There are some complications, but I think in general you can see there's like a bit of attention into making the ergonomics work well. So yeah, I think it can do anything really. It's like a general purpose programming language, and you can write a console app, or you can write like a web server. In theory, it could do anything. I don't think there's many production systems written in Idris, but I think it's quite interesting like to see what more can the computer do. I think like when you start programming with Elm, you notice, oh, the computer should do more. I shouldn't be worried that this function is undefined, right? And I think Idris is trying to push a bit further that idea and the game is how much more can I write in the type system to a point where it's still like nice to use. And I'm not dissing on Haskell, but I think, like if you look at how you implement the similar things, it gets complicated real quick. You have to enable all those, language extensions and stuff.
Yeah. Awesome.
How does it deal with the outside world? There's like IO monads, and it's like basically like Haskell. I didn't know that Idris 2 compiles to JS. I remember
Is that
it was
true?
Haskell at some point. I don't know. I'm literally at page 150 of the Idris book, so I know nothing about Idris.
I was in an online meeting with the developer of Idris. I'm spacing out his name now. But he's a very, very smart guy, but he's also rather humorous. He describes himself as a language hobbyist.
Yeah, he's amazing. You should watch all his talks. They're really, really cool. I wanted to do another little demo for today where I think I've seen Irwin do it. I think his name is Irwin Brady. But he did
Yes,
very
exactly.
little talk about transposing a matrix using the Idris, auto-suggestion feature or like searching feature. I think it's a great example of like how powerful this system is once you construct this type of puzzle. It's just like brilliant. Yeah, but I'm reading the book. It's fun so far. So yeah, read it.
I'm not so sure that Idris is, as you say, it's not really used too much these days. But I think it's gives us a peek into the future of what computer languages really can do. Just like Elm has already done for us.
Something I really like about it is like this ability of like specifying holds. You write this program and the program is not complete, but the compiler is lenient enough to still make it work somehow. It can give you all the information that he has. You can just print it out, and then you can use this information to write the actual implementation of the problem, right? It just gives you, okay, this is all the stuff that I have, and this is all the information that I have. Now It's your turn to do things. And you can also help it to try to construct the problem in a sub-problem, and then you can ask Idris, well, how would you solve this sub-problem? And if it's easy enough, it will do it. It's sort of like Copilot, but it's safe, right? Like it will only do like the safe thing.
Okay, great. Any other questions for Drew?
What was your editor setup?
I just installed Idris Vim, but you have to install Idris 2. That's the only thing. And also, if you read in the book, there's a page where there's like all the code that has changed between the two versions. So Idris 2, it introduces linear types. So basically, you can say, I think this is really cool for Elm actually, because I think this happens to me a lot. Like when I'm writing an update function and you get the model, and sometimes you change the model, but you make a mistake and you end up returning the model, right? And Elm says, yep, it's a model. There you go. And Idris has this idea of like a linear type where you could specify that I'm passing you the model, but you can only use the model once. So let's say you have this update function that takes the model, returns a new model. But then if you try to return the model again, Idris will complain and say, I thought you only wanted to use the model once. So it's weird that you're calling it again. And you will like solve like this. You can, introduce like some of these constraints saying you're only allowed to use this thing, once or no times, or, like something like that. And that's the version number 2 of the language, which I think is almost done. I'm not sure. It's never crashed on me like so far. So I think the compiler is good now.
Does Idris also have ideas how to deal with infinite sequences or things like this?
Yes. So there's the idea of like totality, which, as we all know, it's not possible normally to understand if a function is total, right? Like it doesn't recur forever. Like it's like the halting problem. But Idris has this idea of totality, as in it can detect if the returned value is somehow smaller than the input value. And if that's the case, it is a good indication that we're shrinking the problem to a point where it's going to finish. So if you look at the doc of like a lot of like functions in the standard library, it will add this indication which is total, which means like this function is guaranteed to terminate at some point, and it can, and you can also mark this like yourself, like in some cases. So that there's like this idea where you can, like express this information. It's not perfect, but I think it's like, a lot of like these little things are just interesting ideas on how to solve these recurring problems of, programming, really.
Yeah, I think any help with those type of problems. I somehow in music I deal a lot with infinity and infinite things, and it's easy to make a mistake, and you just get silence. You don't get an error or anything. Your computer gets hot, but it's quite easy. But it's so useful to have infinite things. Like I don't want to always have the finite. So yeah, so that's interesting. Maybe I should just have a go.
Yeah, read the book. I always like put it back, but then I think at the beginning, maybe of summer, we're like, okay, new book club. We're going to read the Idris book. It's been very fun. And also, I think like the whole experience, like once you set up your editor integration, it's like sort of a video game, like a really sad video game, but still a video game where you try to solve the problem and it tells you all the types, and then you try to get the type, the challenge, like get the types to compile, I guess.
Nice one. Well, that seems like a good point to leave it. So please join me once again in thanking Drew for his talk. Thank you, Drew.